use the distance formula to show that triangle ABC is right angled. So we have all the coordinates of the points A, B and C. A is at 1, 2, B is at 2, 5 and C is at 4, 1. It's told me to use the distance formula. I'm not going to draw this. It would be quite handy if we know what the distance formula is. So we know that D, as in the distance between 2 points, equals the square root of, so x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of all of that. This is a Pythagoras thing. So if we think about what we know about right angled triangles, so if a triangle is right angled, a squared plus b squared equals c squared. That's if a triangle is right angled. But actually, if this is true, then the triangle is right angled. So basically, if the triangle is right angled, then this is true. So I could put an arrow going that way. So if this, then this, and also if in a triangle with 3 sides that you call A, B and C, if you can show that the 2 short sides, if you square them and add them, it's the same as the long side squared, then you have proven that the triangle is right angled. So this is what we're going to try and do. So we're going to need all 3 side lengths in the triangle. So we're going to need AB, AC and BC. So it's going to be a bit of a pain and a bit repetitive, but we're going to have to do it. So AB equals, so it's the square root of, it's x2 minus x1 squared plus y2 minus y1 squared. So for AB we're going to use x1 y1 as 1 2 and x2 y2 as 2 5. So we're going to use the A and B. So the x2 minus x1 is going to be the x coordinate of B minus the x coordinate of A. So that's this 2 minus this 1. 2 minus 1. And then for the y2 minus y1, we're going to use the y coordinate of B, which is 5, minus the x coordinate of A, which is 2. So 5 minus 2. And we need to square that. So that is the square root of 2 minus 1 is 1, so 1 squared, plus 5 minus 2 is 3, 3 squared, which is the square root of, this is 1 plus 9, which is root 10. And I don't need to do anything else with that. So that's AB. I'm going to put a box around that because I'm going to use it again for sure. So now we're going to do AC, and then I'm going to do BC. So AC. Exactly the same way, so let's put a line divider equals, so it's something minus something squared plus something minus something else squared. So AC, we're using the coordinates of A and C. So this time I'm going to use my A as x1, y1, and C as x2, y2. So your x2 minus x1 in the formula will be this 4 from C minus the 1 from A. So 4 minus 1. Now for the y's, y2 minus y1, I'm going to use the y coordinate of C. Remember y2, the y coordinate of the second point. So 1 minus the y coordinate of A, which is 2. 1 minus 2 squared. So that is, it's the square root of, 4 minus 1 is 3 squared, plus, and then it's 1 minus 2 is minus 1 squared. So that must be, well, 3 squared is 9, minus 1 squared is 1, 9 plus 1 is 10. So this is root 10 as well, which is interesting. Now we move on to, so we've got AB, we've got AC. The third side we need is BC. So let's do that. BC equals the square root of something minus something squared plus something minus something squared. So now for BC, we're going to use these 2 sets of points. So I'm going to use this as 2 as my x1, the 5 as my y1, the 4 as my x2, and the 1 as my y2. So in here. We're going to have x2, 4, minus x1, 2. 4 minus 2. Now for the y's, we're going to have 1 minus 5. 1 minus 5 equals, well, 4 minus 2 is 2, so 2 squared, plus 1 minus 5 is minus 4 squared. Square root sounds a bit big. Equals, so 2 squared is 4, minus 4 squared is 16, 4 plus 16 is 20, so root 20. So now we have all three side lengths. We need to prove that the two short sides squared and added equal the long side. Now it's pretty obvious which are the short side, whichever the smallest values are, they're the shorter side. So this root 20, the square root of 20 must be bigger than the square root of 10. So this is our long side C, and these are our two short sides. So we need to show that, we're looking to show that AB squared plus AC squared, let's see what that is. We're hoping to show that it is the same as BC squared. So AB squared is root 10 squared. AC squared is also root 10 squared. So that is 10 plus 10. So 10 plus 10 equals 20. Okay, so that's AB squared plus AC squared. BC squared is just root 20 squared. BC squared equals root 20 squared, which also equals 20. So that shows us AB squared plus AC squared. So therefore, AB squared plus AC squared equals BC squared, which tells us ABC is right angled. You might be asked, where is the right angle? So I know that we had AB and AC, AB and AC, they were the shorter sides, and remember the long side is always opposite the right angle, so that was our BC, remember, so this was root 10, this was root 10, and this was root 20, so it's bigger. So the right angle must, well, this is from B to C, this is A to B and A to C, so A must be here, this is from A to B, C to B, B must be here, and C must be here, because otherwise it wouldn't work. So the right angle is angle BAC. BAC is the right angle. Okay, and I know this because if you go from B to A to C, that's the angle that you must turn through in order to do that journey.